Let's see. Hi everyone. Are we live? It seems so. Yeah. On YouTube, yeah. And Twitch as well. Great. So I wanted to do some streaming this week, but yeah, I was tired from last weekend because of the microalchemy, and well, it took like a week to recover, and I'm still a bit tired, but then it seems like Virtual Labs doesn't stream tonight, so yeah, I thought, oh well. And it seems the mouse doesn't want to work anymore. Ah, except when I look at it. Maybe it's a quantum mouse or something. Yeah, it's, oh well. The streaming setup here is a bit weird, so yeah. I have the streaming computer, my own laptop, and I'm running VNC to see the external screen, and then yeah. So some years ago, since 2021, it seems, I think it was during an alchemy or microalchemy. I started working on porting EmuTOS to Apple machines, because yeah, I have some Apple machines, but I don't have any Atari or Amiga, because you know EmuTOS has been ported to Amiga already, but yeah, but not Apple stuff. So I thought, oh well, it's just 68k and some chips, and yeah, why not? It should work. Well, it should be possible at least. But then, yeah, I barely worked on it. I mean, like once a year or something, and yeah, last week I thought, oh well, let's have a try again, and I remember having issues with emulators like Basilisk 2. So yeah, it was just crashing, and I wasn't sure if it would be just just because of the code or something else. And I tried to update the code and whatever, and it never worked. And then I tried QEMU, because now it has Quadras 700 or something target. It didn't work either. It just crashed, and well. So then I thought, oh, there's a new emulator that's called Snow. So why not? And well, I first had to build it, of course, and it's something in Rust. I don't really have anything against Rust specifically. I just, yeah, I don't like the fact that you have to download half of the internet just to run something. Yeah, but I guess it's less worse than Node.js or something, but still, well, at least it runs, so I can do like something like this. And I think I already have a workspace recent, yeah. And so there's the classic, yeah, it's emulating a Macintosh Classic. I had to fiddle with which machine I could emulate versus which ROMs I had, but yeah. Okay, it's not, oh right, that's probably because it's missing the floppy image. Yeah, I did start porting Haiku to Mac68k as well, but that was some time ago. and so there's a happy Mac because it found something that it should be able to boot. And then there's, yeah, the EmuTOS boot screen. And then it hangs because there's some stop instruction because whatever. So oddly enough, I don't remember telling EmuTOS where the screen was in memory, so it just happens to be at the same place as it was expecting. I did have to fix the size of the screen somewhere in memory because it was garbage, but yeah, it was scrambled. But yeah, that's where we are at. So basically, there's a bootloader that loads the EmuTOS, the RAM copy of EmuTOS, and just hands control to it, and it just displays this, and that's about it for now. Yeah. Let's see, do we have anyone in the chat? No, not yet. I did push this on, yeah, Discord as well. Yeah. Who else could be interested? Yeah, everybody's streaming at once, of course. Now I found out that somebody else is streaming, but anyway, it won't be like 6 hours anyway because it's a bit cold in here. I've put the heater on, but yeah, whatever. So if I go to the code, yeah, that's yeah, so that's the first thing I committed. It's just some skeleton stuff to just build the image with nothing inside, and yeah, just something that starts and loops around, but and then there are some changes I made, like telling we're on Apple Macintosh, of course. That's very important. Yeah, so that's where I just had to look how the Amiga board did it. So for now I just force the resolution and yeah, the number of planes and not even where the frame buffer is in memory, so I have to check that out. I should probably change the scene here. So yeah, basically you have to implement a set of calls that EmuTOS will use for things like switching video modes and oops, wrong. The mouse wheel doesn't work for this. Yeah, and well, it's already quite well identified. I mean, you just have to check for these things like target Amiga floppy. Usually you want to do something similar for the Mac. Like for instance, you tell it like, yes, we will boot in RAM because there's already a ROM. I could probably try and build a ROM, but then I would have to replace the Macintosh ROM and do all the hardware initialization, and it's painful. and it depends on the machine and stuff like that, so we really don't want to mess with it. I think I would be only happy if I can just boot TOS from floppy or SCSI disk, like Blue SCSI or whatever. There's SCSI support in the Amiga version, I think, so it should be possible. And yeah, I did have to copy parts from the Emil bootloader. It's basically something like Lilo, but for Macs. So it just calls the ROM for the Macintosh ROM for loading sectors and stuff like that. So yes, there actually is a boot sector on Macintosh computers, Mac68ks. It's just that not many people know about it, but it actually does check if there's a signature of some kind on the disk and tries to load it. Oh, hi Trina. I see, yeah, Trina is in the chat on YouTube, and yeah. So that's what I had to copy from Emil. Basically some ROM calls that we need to use, like PB read sync, that's just for to load the sectors from the floppy drive. Not the mouse wheel. And that's the data block that's used for PB read sync. So you have to fill all the stuff here and call it, and it will update some fields inside, and yeah. There's a switch 32-bit mode macro here, but it's actually doesn't work. I don't think it's needed for EmuTOS anyway. For Linux it's required, but I'm not even sure, and it kind of didn't work when I tried to use it, so well, for now I'm just leaving that out. Yeah, so basically floppy start. Yeah, I could just show the code anyway instead of the diff, because it's not easier to read. Yeah, so that's that's the code that ends up in the boot sector of the floppy, and yeah. Oh, maybe I actually did define this back then. Is it used anywhere? Screen base? No. Or maybe it's just by the EmuTOS code, but then no, it's a define here, and I don't include anything else. So that's weird, but yeah. So basically, a bootable sector for the 68k Macs starts with these bytes. That's version field, some and Pascal strings. So there's a macro here. Basically, Pascal strings are non-null terminated. Well, these will be because there are C strings in this guide, so there will be some null bytes, but Pascal string are defined by a length field and then the data inside. So yeah. And each of these are supposed to be for something like the finder and everything like that, but yeah, it's not like we are really make use of that. Then there are some flags and things like that, heap size, whatever. That's how much memory we want to be able to allocate. Yeah. Oh yeah. I use AA and 5.5 just to make sure at some point it ended up in the image. But yeah, that's the size of the image that follows the boot sector, which is actually 2 sectors. I think it's more than 512 bytes. Anyway, and yeah, that's the parameter block used by PBRateSync. Well, not much to fiddle with. It's just almost verbatim from Emil here. The 32-bit mode, that's because the 68k Macs started with 24-bit addressing, because, well, the first versions of the 68k CPUs, they only had 24 bits of address bus, so the remaining 8 bits in the address pointers, they well, Apple decided that yeah, we can use it for something else, so they stuffed things inside the pointers, and then, well, the most significant bits weren't null anymore, so when you switch to actually using them, it messes up. So yeah, there was like 32-bit clean ROMs and yeah, but it does start as 24 bits at some point, and you have to actually tell the ROM that yes, I want to use 32 bits. Anyway, so basically we have to allocate some RAM to from the Mac ROM, and then we just yeah, allocate the memory here, and then we just call the PBRateSync with the buffer that specifies how many blocks we want to read. Where is that? Position mode. Don't remember. Yeah, buffer request count. Yeah, that's it. So we just have to fill this from the EmuTOS size here, but yeah, we just copy this here. Yeah. And then there's a lot of commented out code, but yeah, basically we disable interrupt, and we copy some info to the TOS variables in RAM, because TOS does about the same as macOS. It just uses the beginning of the RAM to store data, system variables like how much RAM we have. And I think, yeah, for now I just fake like 4 megs. That's the kind of things we'll have to fix. And yeah. Yeah, some fix me here because it's just a test, but yeah, the test works now. So I have to see first how do I get the RAM size from the macrons, and it's probably in some variable in RAM. And also, how do I get the actual frame buffer of address and pass it to EmuTOS, because it's just like a coincidence. It's at the same place. Yeah, I think I had yeah. I think I copied from some website. I remember seeing some websites at some point with detailed how to boot on 68k Macs. Where was that? Create your no. There was a series of articles. Oh well. I think I ended up having to use the archive.org because it wasn't online anymore anyway. Yeah. Is that for actually for EmuTOS, or is that oh, salut Raja. I don't see the people from the Virtual Labs team. I guess they ended up doing something else. The video interface, yay, no, I wanted to zoom in and think different. And there's a post from One Bit Fever Dream. Screen base address. Yeah, but global symbol. Wait, it's not a variable in RAM? Yeah, it seems like there's two screen buffers. I suppose it's for double buffering. In the global variable screen base, yeah, okay. So then I need to pass this to the EmuTOS Amiga boot. Let's see, does it do it? I don't remember seeing that in the boot sector, so it's probably elsewhere. Or maybe it just defines something else. Because I think on Amiga you can just decide where you want the frame buffer to be in memory. Buffer for EmuTOS. So yeah, nothing here. Which BIOS screen maybe in there. if def machine Amiga Amiga screen init. It must be somewhere there. Res changeable. Yeah, so it will return false because we can change the resolution in the Mac case, but that's okay for now. If at least I have the native resolution, I will be happy. Yeah, current size, screen get current mode info. Yeah, the Lisa had a fixed display, so yeah, I added a hook for the Mac, and it currently just returns fixed values, but yeah, that's for later. Palette, we're not there yet. Pixel size, oh whoa. Space, no real physical screen. Oh yeah, right. So that's what we want to override here. Amiga space, physical screen address. So I want to add, I don't remember which, define a use, yeah. Set physical address. Yeah. Let's see how they do it. It's not in this file. Oh right, there's a separate file with the implementation. Of course. Amiga screen base, so it just returns this. Okay, and it's a variable which is initialized. Okay, Amiga screen init. Word. Okay, but what's the default value? Like, yeah, really? It's okay. So it's set by, I don't even know if I can do that on the Mac without calling the ROM, because it depends on the graphics chipset. So there's something. Fall back to log base. Set this. And of course I can return an error here again. But then I suppose I could just cache this and just what was that? If I can't, if I deny the changing of video mode, rest changeable, yeah. It's as long as it doesn't try to change resolution, it should be okay. It won't try to set this, so I just have to cache it somewhere. Top. Okay, so that I can use for the RAM size. So that's the easy one. Is there actually because space, that's cool, but is there a variable in memory for this, or an official one? I mean, yeah, maybe there. Where is that? Bias. I'm not sure where. Channel system variables. Yeah. Stop. Screen PT. Oh. Pointer to the start address of the video memory. Where is it? It's on first written by base. Okay. So yeah, I could just copy there and use that for better compatibility, I suppose. Yeah. So screen PT on I guess it could be interesting to see so yeah, and it's long, so 30 bits. As the version doesn't after setting automatically. Set screen, yeah. So that way I can just hand it over to this code, because I can directly write to variables that will be in this, because it's not it's compiled separately. So yeah. Set TTRAM size. suppose. Okay, yeah, they just didn't bother using defines, but yeah. Oh, wrong file. That's the Amiga one. It's so similar. I mean, yeah. Where's the equivalent section? Yeah, here. Oh no, it's that's the destination actually. And what I want is screen base, yeah. Wait, no. Screen base, yeah. Then in there, screen init. How do I use these variables? I need to. Do they use pointers or something, or if I just grab screen PT, it must be declared somewhere. Yeah, it's actually no. Screen PT extern. It's only using assembly code, it seems. So extern U byte store. So that's a pointer. Okay, it was vars. Toast vars is included, yeah, so we can just and then I can copy set fis. Well, that I can do, but then the fis base, I can just return this. Return screen PT. So at some point it might cause problem because it's not been allocated to EmuTOS. So I'm not sure how I will deal with that, but well. Now, what? Yeah. Also, I wanted to copy the RAM size. Yeah, memtop. And it's memtop STRAM size. Yeah. Okay, so I think it should just be a matter of doing that. Tabulations, whatever. It's copied from some other code. Yeah, if you want. EmuTOS T7. Okay, let's just hope there's no overlap in the variables, because we might end up like overwriting things. Make macflop. Yeah, and of course it won't compile. Oh yeah, right. I have to export the path to the compiler. Implicit declaration of Mac space. Yeah, because I need to add it to some header in the Mac set fit. Oh, I already had the set physical physbase. That's the. So this one, not yet. This one, Mac68k. Okay. Okay, so generating. Let's see. So for now it says 4 megabytes of STRAM. I think I need to maybe I just need to reboot. Or maybe I need to reinsert the drive, not sure. I think I do. Yeah, still 4 megs. I think I had set it to 14 megs or something. Let's try again. In theory, I could also use a resource to say loading EmuTOS or something with the Mac in the dialog here, but yeah, it's quite complex. You have to change the internal resources, and yeah. It still says 4 megs. Machine. Oh, 4 megs. Okay, let's try 2. And yeah, oh no. Cancel. No. Yeah. Let's see. Oh, I guess it resets it. Yeah, it resetted the floppy image. Happy Mac. Okay, 4 megabytes. Did I use a copy or something? I thought it was a symlink, but EmuTOS.Mac. should work. Why? Why? It's EmuTOS. Yeah, this no. It should work. Why did it say 4 megs? It reset to stupid. That's when I changed to the Mac Classic. It reset to 4 megs, I suppose. It's funny. It's the same cursor, but it's actually the top one is the VNC cursor. It's just why does it insist on ejecting floppies? Sorry to all the Atari viewers for all these Mac chimes, but yeah, that's the idea. Hello, Medbell. 2 megabytes. Okay, great. So we actually have the proper amount of RAM. That's great. We should also, in theory, detect the CPU type at some point, but yeah. What else? I'm not sure. Does the Amiga call? Okay, yeah, fix me detect CPU for. Okay, so it's not done by the Amiga bootloader. Okay, clear. So it's pushed on the stack with the so 0 is plain 68k. Can we do we have a variable in memory for the how will I ask Google for that? No, I should use the inside Macintosh books, I suppose. inside Macintosh. Yeah, that might help. Where was that? Window. Okay. Inside Macintosh, Volume 1. Graphics, components, keyboard, mouse, blah 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 blah. Pointers. No. Trap dispatch table, kind of conventions. Summary. I was quite sure there was some table of the system variables somewhere, but control manager, menu manager, blah blah blah. No, no, no. Toolbox. International utilities. Oh wow. Index. Is the text searchable? No, of course. And doesn't want to scroll. Did I look up Ocular or something? Yeah, kind of looks like it. Yeah. I reopen it. So maybe processor type or CPU. PPQR. Processor priority, no. Pure protocol, no. I'm not even sure there's something inside there for this. I suppose I could just leave that for later. CCO and P create. No, so no CPU or something. Oh well. We'll get that for later. So we know the RAM size. Yeah, TT-RAM is basically the RAM that's not available to DMA and custom chips, just like fast RAM on Amiga. I'm not sure there's something similar in Macs, but well, that can wait. Screen PT, okay. The screen size is hard-coded here, but maybe we can look it up as well. I could try to look up yeah, if I just look this up, screen base memtop. Did you mean? No, I did not mean Macintosh for advanced techniques. Whoa, that might help. Technical notes. Yeah, let's download these and programming Macintosh applications in assembly language. That's great. I guess that's yeah. I wanted the other one. AUX toolbox. Oh. And yeah, haven't restarted Firefox in a while, and it seems like every time it downloads something, it's even slower for some reason. It just locks up the whole browser for like minutes. But well. Oh, SCR VRS. Oh, yeah. Definitely interesting. Screen base, yeah, screen VRS. OX. Yeah, it's probably some typo due to OCR and from the picture, but yeah. Wow, that book seems to be quite large. It's probably a scan from, yeah, a large scan. Time is it? Oh yeah, right. Oh, let's see who's this emoji here? Technical notes. Yes, I want this one as well. Java. Interesting. 24 megs. That's not even large. Yes, I want to save this file as well. A few hours later. I see Sloopy Malibu screaming on the links on Discord, because yeah, I mean, that's an heresy, right? Porting Atari stuff to Macs. Yeah. Well, you know, I thought we crossed that bridge already, but on Macintosh programming, advanced techniques. Wow, that cover. Yay. Beautiful. Addison Wesley. Yeah, screen bitmap, not this one. Screen base, yeah. Okay. G screen. A lot of interesting stuff in there. Let's do this one. I want to do the next two. Yeah. Alternate screen base. Yeah. 117. 117 is not 117, of course, because there's probably some pages. Technical notes. Page 1 of 1. What? Technical notes. It's not even. That's weird. Why index? Why is does the index give 3 figures, pages, and then well. Okay, well. Assembly language. Wait, did I already download this one? Which was it? No. Or maybe I already have this one. And then reverse engineer. No, this one I wanted. AUX. I wanted to have a look at AUX at some point, but yeah. So much stuff to do. Yeah, HTTP, allow download. I think this one might be the most useful. Macintosh run interface. Maybe it's not searchable, is it? Oh, yeah. Oh, cool. Screen vertical dots per inch. Ah, resolution. That's that's the proper resolution, because we usually say resolution for the screen size, but it's not really the proper term. But yeah, screen. Let's search for screen. Raw bytes of screen, total screen bytes. Yeah, screen raw, screen bytes. Screen vertical lines. Screen bytes. Okay, 0C24. Which screen bytes? Screen raw bytes. Raw bytes. Oh, yeah. The number of bytes per row on the screen. Okay. 106. 6. Which screen? Row. That's a long, that's a word. Screen HRES. Yeah, same. I don't really want that. I could probably calculate the vertical size by dividing the two, but screen. Is there any other row bits? Horizontal. What? Row bytes? What the? Row bytes per screen. Screen horizontal pixels. Row bits. Oh, that's the number of pixels, but not the number of bytes, so I can deduce the number of bits per pixel from that, I suppose. Yeah, OC20 row bits. OC20 screen horizontal pixels. Let's copy that. Hi, Sloopy Malibu. It's not insulting, it's bringing more software to it. Yeah, I mean, yeah, I don't have any Atari here, so how can I just use Atari software except for using, yeah, Macs? Ah, well, and then I can use maybe like a Macintosh emulator on the Atari running on the Mac. Well, screen roll bikes. I think maybe. Oh, but yeah, there's no text in this one, so does this one know about it? Yeah, okay. 106. Okay. Now, do I have similar variables for the TOS, so I could just copy them there instead of having to pass stuff around? For place, no secret. That's valid. That's for resets. RAM top. PAL mode. And that's the cookies for warm reset. Doesn't look like it. Color pointer, color palette. Okay, I'm not there yet. Screen PT. Project call. Yeah, it doesn't look like that. Yeah, it seems the macrons were written in Pascal. Much like Windows, actually. I think. Well, Windows did use C strings, I think, but yeah, I remember seeing Pascal stuff in Windows documentation, but so that means I will need to well, at some point there's screen init. Maybe these are still valid here, depending on the initialization order. I mean, maybe these variables are still available here and I could just cache them. I could try that. horizon. Okay, that's an odd shortening, but yeah. VT res. I could try to cache them. I guess it will be quite fast to see if it works out or not. So horizontal resolution, total screen byte, row bytes of screen, and so words. So so I just did it. This address does a uword pointer, and I want to dereference it. And same for the well, the other one I need to divide by this. So basically, screen bytes. Screen bytes. Let's see if this works. And then the res Mac VT res. Semicolon here. Nope. Middle click. Yeah, I think I need to force the new image in. Now, remember, oh, that's interesting, but okay, that's really interesting. Funny effect. So it didn't really work the way I wanted. Remember that there used to be ways to run macros on Atari machines, so it's just justice that we do the opposite. Why doesn't it do this? I guess I didn't really understand this. I could try to get current mode info. Do we have a printf or something at that stage? Probably not. I guess I could try, but maybe there. But yeah, it's possible they just clear the RAM at some point. So that means I will have to find another way to pass these, but maybe it's just that they are wrong. Printf is not declared, of course. Where will I get this? It's std. Where is that? Kprintf. Okay, there's a kprintf. Better use that. Kprintf out C UA. Oh right, I could try to use the serial port. Probably, yeah, probably it won't work if I don't initialize the serial port. Yeah, I suppose kprintf is only for so maybe it doesn't work on the screen. Yeah. Port channel terminal. Oh, right, so I could do this. I'm not really fond of the MDI interface on Snow. Oh well. Yeah, how could I could try printf, but it's probably too early. stdio maybe. Config kprintf. There's no sprintf. Yeah. There's no actual printf per se. Yeah. That's weird because I grab actually. That's utils. Yeah, that's not on the TOS side. Sprintf. Yeah, okay. Oh, cprintf. Is that for console or something? Okay, cprintf was the for debug purposes. Okay. Do for directly to the console. Okay. So I could try cprintf, but then where is this defined? cprintf. Okay, it's defined there. But it's probably too early because it's calling the function that has it with the resolution of the display. So unless it's buffering or something. People, spammers in the chat. How do I do that? All right. Click on the nickname and yeah. Yeah, doesn't seem to work. So that means I need to implement the console for that to work. Okay, printf for UAE debug. Okay. Yeah, UAE has a specific debug port or something, but maybe this one has infos on the serial ports. Actually not sure, because yeah, that's the problem. Is I can just use the ROM and tell it to send serial stuff, because at one point the system variables will be the TOS ones, and stuff will be overwritten, and the ROM will not work, will not be callable, because it will try to use stuff that's not in memory anymore. And yeah, memory management. It doesn't describe the hardware at all, so yeah. Developer technical support, technical notes. Okay. AB boot process. That AR driver. Helper there maybe. Bug. Multi-finder, PP, NLP, or S, resources. SCSI. I could try to implement SCSI boot, so I could just use disk images, but well, it works in the emulator, but it would be funny to have it running on my Macintosh portable, maybe from a blue SCSI. SCSI serial connector, serial driver, yeah. Yeah, that part I would need to check how the emulator does it, which chip it's using and stuff like that, but Um, Turn down. Well, Sarah Connor? Seriously? So at least if somebody knocks at the door and asks for Sarah Connor, you can tell she's on page 273. Oh dear. See your dentist. What's that? What's that book? That's weird. I need to know. Sarah Connor 273. Why do they even mention that? Oh, it's not even. It's after the page count. Ah, right. It's that document where the pages don't match. Ah, that's crap. VAA. Actually, that will be much more interesting. But yeah, I don't remember if they use proper UART or yeah, wasn't it a Zilog chip or something for the serial ports? SCC. Oh, CPU flag. You can determine which microprocessor is installed by examining the low memory global CPU flag byte at 12F. Ah, well that's handy. Now we need to know how to pass it to EmuTOS, but at least that will be done. CPU flag 12F. Let's do that at least. 12F. Flag, yeah, 12F. But then it's passing as a long, but boot EmuTOS. Boot RAM. I need to go check that. It's somewhere in CPU D5, so it goes into D5, CMP D0D, move Q 20. Okay, so it uses 20 for the 68k 20, and yeah, so I just need to multiply by 10. Yeah, 30 CMP not equal. Okay, yeah. So I need to multiply this because it's just 1, 2 is the second digit. That's yeah. Okay. Other exception activity. Okay. Mel. What's the 6k mnemonic? I think it's mel dot whatever. Melu. Yeah, there are 2 multiplications or something. 2 unsigned. Yeah, unsigned. Okay. and so and it's supposedly long. Oh, it's a byte. Okay, move that. So I need to clear. D0. Move dot B. CPU flag. D0. Mulu. 10, and I think it should go into T0. Effective address DN. Okay. Yeah. So and it's a long, so then I need to push that move.L T0 on the stack. It shouldn't too much on this one because it's classic, but at least it should still say 68k. Bonne nuit, ma belle. And it's almost midnight here, so oh, Justin is streaming tonight. When's that? Okay, so still this. I'm not sure I have the proper ROMs to emulate larger. Another, yeah, Macintosh 2. Is this is this an 020 maybe? Oh yeah, but I need the other ROM. Where it will complain. 8 mags, browse. Why does it reset the path? There's already a path in there, and no, it just doesn't want to. That's annoying. Old word Mac ROMs. I don't even know which. No, it's not. Probably not this. Mac 2. Classic 2. Mac 2 SI. It's just a Mac 2 alone. I really don't like these UIs. Just use the native file selector. It's painful. Quadra, no, that's. It's probably a smaller ROM then. Mac 2. Okay, yeah. Which is it? And it wants the display card ROM. 0868. Old world. Why can't you just find it from there? I'm not even sure it's in there. Mac Plus, that's PowerBook, yeah. So I just can't even emulate the Mac 2 because I don't have the RAM for the video card. That's PowerBook 100 SC portable. Damn. Perform group server and Pro Macro. Yeah, it's not in there, I think. No, it's not even in there, so I can't even emulate the thing. I would have to find the ROM for this video card. Can I just keep this custom video card? Yeah. Disable ROM validation. Yeah. Yeah, so it just won't work. Display card. And of course, I need to copy, paste. ROM archive. Okay. This suspiciously looks like dumps of other Mac chips. There it is. Yes, I want to save the file. Hello. That's a weird. That's a weird name. Oh well. I was about to bookmark it, but it seems I already had this one bookmarked. Let's. No, what is it? Firefox, really? Why is it going there? I don't want to go there. I just wanted to, yeah. Just in a string, 2 hours there. So 341. Oh wait, oh no, it's another one. Okay, that's something else. Open. Maybe it will work. And of course I need to set the drive image. We have a much bigger screen. So it won't work because it's hard coded, but yeah, whatever. What's the resolution? Oh, that's plain VGA. Okay. Drive. Yeah. So I need to go there and force VGA here. But let's see how it handles. Actually, it doesn't seem to want to boot from the floppy. Did they scrap the boot sector support at some point, or? That's weird. Or maybe it's just enumerating the RAM and it's slow. It would be really handy in cases like that to have some debug messages somewhere on the serial port. Just, yeah, well. But you know, people want graphical stuff and clicky. Yeah. There's no sign of anything going on. It's not even trying to boot from the floppy, or? Oh, okay. Yeah, it's just, I suppose it's just taking time to test the memory. And then it should display weird stuff because, yeah. It's much slower than the Mac Classic. Well, maybe it's because it's emulating an O20, but emulator had it. CPU stepping. Okay, move C. What? Move C? What is that? Invalid control register. I did not tell you to do that. And why can't I just click there and go to the assembly dump, view, disassembly. Okay, let me just to make sure it's not something due to this. Maybe we shouldn't multiply or something, and reload the floppy image, restart. Oh really? What? Oh no, that's the previous one. So slow. No, okay. PC 2 and E4. Indirect control register. C. That's weird. Okay. I guess there's something it doesn't like about O20s, but yeah, I actually haven't tried booting a Mac image from there, so maybe there's something wrong with the ROM itself or something. That's weird because it actually loaded the thing. So 21E4. Memory, but why is there no disassembly here? Too much. No, I don't want to edit it. More, no, what's that? Yeah. Yeah, would be nice to have the assembly view, but it seems instruction history. Oh, maybe I need to restart it. But then it will be even slower. Yeah, that's really not practical. Bit test. Okay, so that's probably the RAM test. These windows. Alright, I suppose I can do that. Yeah, it should really work, but well. I should probably stop at some point. Slow. bit. I just want to see when it crashes. Oh. At least it's doing something, but yeah. PL wrench. Looks like some copying. Possibly the TOS is actually testing the RAM itself as well, but yeah, I should have kept the RAM to 2 megs. It's so slow. Well. That's going to take a while. It's weird. Maybe the screen is. Maybe actually try to initialize the screen and it's not on the same address, but it should be. No, actually, are copying the address. So. Okay, so the last thing it did was load effective address. Okay, 222.280. Where does that come from? Move C. CSC ACR, that's case address control register or something. So that's definitely 020 code, because it doesn't exist in the plain 68k. But then, what address is that? It shouldn't be there. CSCR, I could try to do a grep. Startup. But which run? Uh, 808. That's weird because I thought I commented out this stuff. Or I.B invalid instruction cache. It's not this code. Can I zoom in? Yeah, no, of course not. That's a plain move, it's not an OR, so it's not this code here. I'm not even sure it seems to be in RAM, so it's probably not from the ROM. Move Q, move CD0 VBR. Yeah, that's not plain 68k either. VBR. Vector base register. SMDev. Yeah. So the only place it's used in it's in startup.s. Move out, VBR, 0. Where is it? VBR. Move Q 0. Move L 16. 0x 10. Yeah, that seems to be okay. So then it's this code. If you're okay, now reset. On Falcon we need, no, that's not on Falcon. Cold fire. I probably have, yeah, not defined machine Lisa. I probably have to check that as well, but okay, cache done. That's weird because it shouldn't be if not defined cold fire, not disable cache. Yeah, but that's yeah, that's 020, but I shouldn't try to do that on plain 68k and then instruction invalid control register. It's not CS here because this one worked, so it means it's the thing next to it. So yeah. Not pmove is line F on non-authorized systems. TTR 0. Oh, RX2C. Oh, it's, yeah, it actually did set up a VBR at some point, so oh, okay, it's overwriting the interrupt vector for invalid instruction or something, and instead of checking if the CPU is what it seems, not authority, but then encode CPU stepping error. Yeah, but why just options? Maybe I just need to tell it to continue, but no, it just insists. That's weird because state option breakpoints trap maybe 9F trap breakpoints, no, and trap. There's no breakpoint set for exceptions or so it just shouldn't stop emulation. It just should just run the vector there, but okay. So that means it doesn't like the auth30 opcodes, and yeah, which is weird. When emulating the classic, it didn't care about it, but that's, I suppose it's just not the same CPU core, so I guess this one doesn't like it. Instruction CPU stepping error. Yeah, but in the control register, it should just generate an exception and let the vector be used for that. So yeah, I could bypass that, but yeah, I will probably have to fix the emulator, but then I have to learn Rust because I don't know Rust. Oh well. Yeah, midnight already, and it's getting cold here. I have the heater, but yeah. So yeah, it's weird because it wants us to pass the CPU type, and then it just doesn't care about it and try to execute all 30 instructions. So that's weird. But well, so it's definitely not because of that. So I guess I can leave that for now, and yeah. So I suppose I will revert to the Mac Classic for now, and I'll check the O20 later on, because yeah, Macintosh 2 was Classic. Anyway, so yeah, not much of a progress tonight, but yeah, it's going to take a lot of hours anyway to get something usable from it. But yeah, I could show you something totally unrelated, but yeah, the other day I modeled some part for TC 800. I was missing the top cover for the buttons, so I just modeled it. I tried to set it here because there's an angle, but yeah, it didn't really work well. Anyway, but it's on my GitHub account and on Thingiverse as well. So yeah, if you have a Panasonic TC800T or EU whatever, there are variants with a tuner, and it's a cute TV, and it goes along quite well with my MO5. It's just that I need to recap it because the output is quite ugly, and it's probably the cats that are going bad. Yeah, anyway. Oh, and yeah, that's the kind of stuff I initially had because the display settings were of course wrong. So yeah, that's because of this here. Now the problem is I still don't know if these are still okay or not here, so then I will have to find a way. Actually I can monitor the memory location. Yeah, right, I could do just that. View memory 106. Go. Why doesn't enter work here? Really? 1006. So that's 25. Oh, that looks like something to clear from or whatever. What's the? Oh no, that's. Don't tell me that's vectors. Yeah. All right. So it's so low in memory that it's in the vector table. So yeah, and of course it's not 1. Yeah. So at least that is gone already. Screen row. C24. But yeah, C24. No wonder. C24 FFFF. Okay, so that's been overwritten by some other stuff. So I definitely need to cache this somewhere. Not over the rainbow. How could I do that? I don't think they do it in any way there. They're not doing anything similar. Screen PT. Maybe I could push these on the stack before the regular arguments, but then I will have to find a way to get them. Bootram. And I don't know where it's, how it's called, and the call graph from here to the screen init here. So it would be nice to have a way to pass various stuff, but yeah. Yeah, that's tricky. That's there must be a way. I mean, I could just use arbitrary locations, but yeah. Because I can't really. Maybe if I can get the address of these in memory, and as the offsets from these from the start of the TOS image, I could patch them from here, but it's, yeah, that's ugly. RAM size, yeah. I could just like stuff them right after a screen PT or whatever, but yeah, I will need to make sure there's nothing else there usable. Yeah, I will have to think about it, but I think I will just wrap it up for tonight, because it's getting cold in here, and yeah. Thanks for watching. Well, let's fix that at least for now, because yeah, let's end up on something that's working at least. Drives, and then yeah, it was a happy Mac. So yeah, not much of a progress tonight, but yeah, it will take some time. So probably I won't be streaming all of the dev, but at least some of it, I think. And yeah, I still have to publish that somewhere on GitHub, so I have to fork the yeah, it's very slow, but it's, yeah, that's the kind of thing, well, you have to look stuff up and check, and there's actually two systems you have to look up stuff for, so it's twice as slow, because this you can do on the Mac, and yeah, on Atari it's done this way, and yeah, anyway, so that's about it. Yeah, I have to fork the EmuTOS repo and push that somewhere. And if you want to have a try and maybe contribute, who knows? Anyway, thanks for watching, and yeah, see you later.